Hi all, this video is about the public key cryptography. So in public key cryptography, we all know that it is also called as the asymmetric key cryptography, and in that the sender um, keeps a public key for preparing the encryption process, and the receiver side makes use of the private key to do the decryption process. So there are two keys involved in it. In this video, we'll learn about the famous public key encryption algorithm, which is the RSA algorithm, which gets the name from the researchers itself, Rivest, Shamir, and Adelman, who proposed this algorithm of in 1977. And this is the most popular algorithm of the public key scheme. And this works based on the exponentiation in the finite fields over the integer modulo of prime. So now you can recollect the some of the basics. When we do the algorithm, RSA algorithm, you will recollect the points which we learned in the finite fields concept, and it makes use of large integers. Example 1024-bit inputs also, and this is more secure compared to the all the other traditional encryption techniques because of the factoring of the large numbers. It deals with the factoring of large numbers, so that's why it is very secure to hard to break. And here comes the encryption and the decryption part. The encryption equation is C is equal to m to the power e mod n, which means M refers to the actual message and E is the encryption key. Okay. And then for decryption, it is the equation is M is equal to C power D mod n. So the cipher to the power, the decryption key mod n will be used. So this is the steps for performing the RSA algorithm. So the first step is selecting the So the first step is to create the public key pair and the private key pair. So in that, initially we need to choose two large prime numbers, any random prime numbers, and then we have to compute its modulus, which is calculated using the formula n is equal to p into q. And we know that through the Euler's torsion function, we would have learnt about this Euler's torsion value, that is phi of n, which is calculated using p minus 1 into q minus 1. Then we need to select a random encryption key. It is a random key, but it also satisfies the two conditions, which is it falls between 1 and phi of n, and also the GCD of that number and phi of n is equal to 1. So that's the key. E is the key which is used in the encryption process. And then comes the decryption key. At the receiver end, the decryption key will be used. So that's calculated using the again the Euler's function is applied over here. The formula is E into D equal to 1 mod phi of n. So that to calculate D, the formula becomes D is congruent to E inverse mod phi of n. So now our task is to find the E inverse so that we'll get the equivalent D value. So now the public encryption key pair is denoted by PU, which includes the E and N value, and the private decryption key pair is denoted by PR, and it includes D and N value. So we talked about the RSA security. RSA is more secure when compared to the other ones, but it is also prone to some of the attacks. The basic attack is the brute force attack, that is trial and error method. The brute force refers to trial and error method. The next one is a mathematical attack by computing the phi of n value and the factoring modulus. They'll be trying to break the RSA encryption process. But again, if you fix a very difficult n value and the factoring modulus, then the phi of n and the n value, then we can preserve or secure the RSA algorithm. Then it also prone to timing attacks, that is on running on the decryption side. Then finally the chosen ciphertext attacks. So chosen ciphertext refers to the whole understanding or the properties of RSA is given, and from that the hacker will try to make a attack on it. So now let us solve one example. The first step is the encryption process. Let us consider we have to encrypt a plain text message which is equal to 7. Okay, and let's choose the first step is random prime numbers we have to choose. Let us choose p equal to 17 and q equal to 11. Okay, from this the modulus value we can calculate, that is the n value, which is calculated using p into q, and the answer will be 17 into 11. That gives us 187. So n equal to 187, and immediately we can find the torsion function, which is p minus 1 into q minus 1. So 17 minus 1 is 16 into 11 minus 1 is 10. So the torsion value is 160. Okay. Then the first step is to find out the encryption key. The encryption key is denoted by E, and it is calculated based on two values. So the first condition is the E value should be within 1 and phi of n, and then the GCD of E comma phi of n should be 1, which means between that number, selected number, and the phi of n, here the phi of n is 160, which means it ends with 0, so it is the factors are 5 and 10. Okay. But you have to choose a number called E, so that there cannot be any common factor for both the E value and phi of n value. It can be any number. So I am going to choose a number called as 7. So 7 and 160, it cannot be it cannot have a common factor. So I'm choosing that number. You can choose any number as per your wish. So that's it. Now the public key is ready. So what we can do is we can do the encryption process, and the encryption formula is C is equal to m to the power E mod n. So when we apply that, 7 to the power 7 mod n. So the n value is 187. Okay. Sorry, the m value is taken as 88. The problem which I have solved for m value equal to 88 to the power 7. In the previous video, I have shared how to solve this exponentiation in a very simple way. You have to break down the power value in the base of 2 exponential increase, that is 1, 2, 4, 8. Likewise, you have to split up. And when we solve this, I got the C value as 11. So this is the encryption output. And the next part is we need to perform the decryption. So now the cipher is available. And the concept is the cipher value will be transmitted over the transmission channel and reaches the receiver successfully. And at the receiver end, he'll be performing the decryption process. So now the receiver side will be having this, the cipher value C equal to 11. So in order to get C equal to 11 or 88, we have taken a one character value, but it will be a sentence or a paragraph. So such many blocks of encryption and decryption will happen. We are doing it for a sample for one character. So now the receiver has got C equal to 11 with him, and next he need to perform the calculation. The formula is C to the power D mod N. So now we have to find out the D value. In order to find the D value, we are using the Euler's formula, E into D equal to 1 mod phi of N. Okay, so here we need to find the D value. So it will be E inverse mod phi of N we need to calculate. E value already we know, which is 7. So we need to calculate 7 inverse mod phi of N. I hope you have learned in the about how to calculate the 7 inverse mod some number. Here the phi of N value is 160. Okay. So when you're finding the multiplicative inverse value, so multiplicative inverse value, we can do it in three ways. One is the first trial and error easy method, and the second is the multiplicative modulo table method. I have done it in the previous videos. And the third method is solving it using extended Euclidean algorithm. Based upon the complexity of the number, we can go for which of any of these three methods. So now, since it is a smaller number, I'm going with the trial and error method. So how we have to calculate 7 inverse value? 7 inverse, the meaning is 7 when it is multiplied by something and mod with 160, it should give the value as 1, which means 7 into something when it is divided by 160, the remainder should come as 1. That's the concept. Okay, so we have to put the values from 1 to 7 into 3, what is 7 into 4, likewise we have to get. Okay, so when I tried this, I got the value as at one point 7 into 23. 7 into 23 is 161 now. So 161 when it is mod with 160, definitely we'll get as room, which means we are dividing 161 through 160, so the remainder is 1. So 23 is my D value. We just got the decryption key, that is 23. Okay. Now we can perform the decryption using the formula. So the output of decryption is the original message. Okay. And so we are having the cipher in hand, C to the power D mod N. So that's the formula for a decryption process. So the C value we have got is 11, and 11 to the power 23 mod N value is 187. Okay. So 11 to the power 23, as I've told in the previous video, we have to split up the powers. So 11 to the power 23 can be written as 11 to the power 1, and then we need 23, so 16 and then 32, so we can take 11 to the power 16, so this becomes 17, so 11 to the power 8, it is 24, so this becomes 24, so 8 need not be taken, so it can be 4, so 20, 21 into 11 to the power 2. So this will be perfect in calculating because it is 17 plus 21 plus 23. So when you split up the power and do it in this way, it'll be easy for us to calculate it, because the first step you will be finding out 11 to the power 1, and then how to find out 11 to the power 2? It is 11 power 1 into 11 power 1 itself. So likewise, we have to calculate the values, split the power and calculate the value. So it is going to give you the final result as m equal to 88. Thus, the RSA algorithm makes use of two different keys, public key for performing encryption and private key for performing the decryption process. So this is all about the RSA algorithm, which is a public key cryptography algorithm. Stay tuned for more videos.